mentioned, I think we'll jump right in and I'll start sharing screen. Yeah.
Cool. So first, just quick thumbs up emoji. Everyone can hear us okay? So as long as one person can do it. Yeah, perfect. Thanks, Peter. Cool. Well, yeah, as Alice said, welcome to our first Power BI and Data Analytics for Enviro session for 2025. Those people that are new, like especially welcome. Yeah, no, always nice to have new people either working in Power BI or data analytics across the environmental or water industry. Our mission here is we try and meet monthly to help just the general organisation and people by learning from each other. So we share case studies, learn new tips and tricks, largely in a Power BI sphere with like environmental-based case studies. And it's all about really empowering other environmental professionals or enviros on their Power BI journey. So that's really what we're after. So just general housekeeping as a courtesy to the speakers, as everyone has already done, please just mute yourself. Any questions, feel free to type them in the chat, or alternatively, there'll be lots of opportunities to come off mute and just ask questions directly. We try and keep these sessions pretty casual, pretty informal, and very engaging back and forth. Session is being recorded, just so everyone is aware. It'll be shared afterwards just via the YouTube channel and by our meetup group as well. And you can zoom into any small content that's being shared on the screen by holding control and clicking through. We'd also just like to acknowledge the Bibbulmun people, the traditional owners of the land on which we are dialing in from today, Alice and myself here in Perth, Western Australia, and pay our respects to the Whadjuk people, their elders, both past and present. Here's a view of Janalup. Actually took it's about 6 kilometres from home on one of my runs, so it's not a bad place to go. So yeah. Also, thanks to Alice and I, co-founders of Discovery Eye. Those people that don't know, we really specialise in largely Power BI dashboards, Power BI reports across the environmental industry, as well as training and basic consulting. So if you want more information there, feel free to have a look at what we can help you with. To the main session for today, though, I'm very excited and very grateful to have Amy StLawrence from the Blue Mountain City Council, who we worked with over the last few years in developing the dashboard. So really what today's session is exploring this dashboard. And Alice, who'll guide the majority of the session, and Amy, it'll be a bit different to what we usually go through. It'll be more of an exploration of the dashboard development process, from initial data sets, initial mock-ups, to how it's sort of culminated into the final dashboard, which is publicly available if you haven't seen it yet through the link on the slides, and also the link in the meetup group if you wanted to have a look for yourself at home. But we'll have a look at the final dashboard, that process of creating it. Oh.
Hello.
Hello.
Hi.
Hello. Hi.
Yes, hi. Sorry.
John?
You have a question, John? Hi.
Yeah, I'm actually on my phone. I just got to log in. Hang on a sec. This Matt, isn't it?
All good, John. You're in. Yeah. Just if you don't mind muting yourself, John, I'll keep just going with the introduction. Thanks. And then Alice will dive a little bit deeper into some Power BI techniques that might be of interest in terms of how you can present environmental data sets. So hopefully, depending on your organisations, your expertise with Power BI, or if you're more from like the environmental regulatory perspective, hopefully this session gives you a little bit more understanding of how you can go about creating these dashboards if it's something you're interested in, and just a nice showcase of how to present this type of environmental data sets. So I'll leave it with you. And
yeah, fantastic. Thank you so much. I'm just going to plug in. And as Krisha mentioned, we're going to start with the end at the start. I've just... Perfect. Can everyone hear me okay? Awesome. Okay, so we're going to go through the final dashboard. I'm going to post the link to the dashboard, the direct link to the dashboard in the chat, if people wanted to click along with us as well. So this is the final dashboard. It's the Blue Mountains Waterway Health Explorer, which is publicly available on the Blue Mountains City Council's website. So it's got an acknowledgement of country first whenever anyone launches the dashboard. So it's like a pop-up. And this is the landing page. Just before we get into the dashboard, Amy, did you want to give us just a quick overview of the purpose of this dashboard and how it's used within the organisation?
Sure, thanks Alice and Christian. Can you hear me okay?
Yeah, perfect.
Excellent. Yeah, so I'm Amy StLawrence. I work in the Healthy Waterways team at Blue Mountains City Council, and I've been doing this job for nearly 20 years. So over that time, we've gone from having very basic systems where we sort of stored each year's water quality and macroinvertebrate data as we collected it in different Excel spreadsheets. So we just had like bits and pieces of data all saved all over the place. So anytime we wanted to actually compile and communicate and share that data, whether it's within council, with other staff, or whether it's for our community, bushcare volunteers, general residents, when the data was all in different Excel spreadsheets, that was really difficult. And if we wanted to go a step further and actually help people visualize that data with graphs, or that was even another level of effort to sort of put all of that together on a case-by-case basis. So this Power BI report represents a massive leap forward from those Excel spreadsheet days. We sort of had a step in between, which was actually compiling our data into some databases. So it's sort of all in a central place. But yeah, what started us on this sort of process was really just wanting to have that visual representation of our 20 plus years of water quality and macroinvertebrate data, so that we could more readily share that with people and sort of use it to support our messages that we're trying to get out there about what the current state of our waterways is and what people can do to sort of improve that or protect our waterway health.
Yeah, definitely. Oh, that's excellent snapshot. And it's you raised a good point, because organizations like yourself spend a lot of time collecting and collating this data. Before we jumped on the meeting, we were chatting about how your next round of field program is kicking off, and you spend so much time collecting this data. It's really nice to see you being able to visualize and communicate and see this data now in a tool like this.
Absolutely. And we used to produce, each year we would produce a written report on our results, which was, this huge brick-like thing that once it was out there couldn't be updated. And so we're actually not producing detailed written reports anymore, where we do sort of like a summary pamphlet on the year's waterway health results that we mail out to all our ratepayers. So it's just a small pamphlet, and then the detail comes through this Power BI report, rather than us producing these huge brick reports that probably about 5 people in the local government area would read. And this is a lot more accessible, and it's live, so it can be sort of updated all the time as we're getting new data to plug into it.
Yeah, fantastic. No, it's so good to hear. So on the homepage, we've just got a bit of information about the Waterway Health Explorer. Because this is a public tool, it's really important to do things like embedded dashboard navigation videos, so the general public can have a look at how to navigate within the dashboard itself. So this walks new users through where to click and how to extract different information. Within the dashboard, again, because it's a public dashboard, we've used lots of icons to make it really clear what the different themes are. So we might just do a quick overview of the different themes. So the first page is a results overview. So this is your citywide results at a glance, where you've got ecological waterway health, ecological water quality, and recreational water quality. And this page, Amy, is this really just to show at a glance the health of the different waterways?
Yeah, so it gives sort of a broad overview of, and I guess kind of lets people know what kinds of data we've got across the different sites as well. So yeah, and it gives us a way of tracking year to year, like what proportion of sites were good, what proportion were poor, and so you can fairly easily track that across time, which is handy.
Definitely, and it shows an overview of all of the sites for monitoring, and when we hover over the sites, I think, yes, it's my internet being slow, we've got our images, so you've got site photos just to show to the community what these sites actually look like. The next page, the ecological waterway health page. Did you want to chat through what this page shows?
Sure. So ecological waterway health, for each sample, we come up with a waterway health rating, and that's all based on the aquatic macroinvertebrates that we collect in each sample. So we're looking at things like what's the diversity of invertebrates like, generally the higher the better, how many different types of mayflies, stoneflies and caddisflies are there in each sample, what proportion of the individuals in each sample are mayflies, caddisflies, stoneflies, and also the signal sort of sensitivity scores. So we sort of mush those 4 components together and come up with a overall ecological waterway health rating. And that, we sort of apply that consistently across, we've got over 70 sites in our area now, including sort of a handful of undisturbed reference sites. So that's, currently that's how we're calculating ecological waterway health. And then, while we're out catching bugs and identifying bugs, we also take some water quality samples, all the basic stuff that you can do with like a multi-parameter probe. And then because we've got so many years of data and reference site data, we've been able to set our own local guideline values using sort of 20th and 80th percentile values from our reference and slightly disturbed site data. So just, these graphs, you can select the particular site that you're interested in looking at water quality at, and then you can see how does that site's results over time compare with the local guideline values. And that's actually really handy just for us as well to get a quick interpretation of our data for each site. In terms of the water, like the water quality shown here, where most sites we're only collecting 1 sample per year. Sometimes it's more, but it still gives us an idea of trends over time, and where we've got sort of particular project sites or pollution incidents or that sort of thing. We do a lot more in-depth and frequent monitoring. So yeah.
Oh no, and the thresholds and guidelines and exceedances, we saw that on the first page as well. We've got having a look at things like the percentage of parameters compliant with local guidelines. This is something that crops up on a lot of different environmental studies. So I'm going to have a look at ways that we can process this data up in Power Query a little bit later in the presentation, because I think that will be might be interesting, might resonate with people on the call who have similar data sets. And this is one of my favorite pages just because it's so visual. Talk us through this page, the waterbugs page.
I agree. I think this is one of my favorite aspects of the dashboard as well. So for each sample, or there's different ways that you can sort of arrange this data. I think the way Alice has it displayed at the moment, we're looking at all sites, is that right?
Yeah, that's right.
Yeah,
So you typically select one river and maybe just one year.
Yep. So we can choose a site or choose a bigger catchment, or even look at all of the bugs we've collected throughout the whole monitoring program or across all sites in a certain year, and we can drill down to the level of exactly what bugs did we find at these sites. And there's pictures of almost all of them, largely thanks to John Gooderham, who's took a lot of these photos. And I just feel like it sort of makes the data a bit more tangible and real. Like, and I just think it's so cool that, you know, for example, with our education program, a school class can look at their local creek and see online exactly what bugs we've found there in the past. And then, you know, we might take them out and actually do a hands-on activity where they're looking at real bugs in the field. But yeah, I think this is really cool, and it's also quite a handy tool for when we're asked to sort of cough up those fun facts, or, you know, like we can quickly and easily say, you know, in the last 10 years we've found 50 families of macroinvertebrates, and we've collected, I don't know how many, tens of thousands of individuals we've identified 20,000 bugs.
Or 236,000 bugs. Yeah, that's a lot of bugs.
That's a lot of bugs that we've bothered over the years.
Yeah.
So, yeah, so it's just a quite different and handy way of drilling right down to the nitty gritty of what those waterway health ratings are actually based on.
Yes, yeah, I totally agree. And just converting what the data is into something tangible with the photos. I can't even pronounce lots of these names of the bugs. So that's really cool. Can we have a look at the recreational water quality page? What are the key takeaways on this page?
So this is a program that runs kind of separate to the macroinvertebrates and the ecological water quality. Over summer, we've got a bunch of waterways where people like to go swimming. So every week we visit 6 sites and test enterococci as the main indicator, based on the NHMRC guidelines for managing risk in recreational water. So yeah, we test enterococci. That data is now actually available on the New South Wales Beach Watch website. So we've got a partnership with them. And so each week they update what the star rating for all of our swimming sites is. So that's handy for people who are just like at a site. They can scan a code and see what the latest water quality was like there, and whether it may or may not be a good idea to go for a swim based on those results. But this aspect that we're showing on the Explorer, it's a lot more visual than sort of what you can see on Beachwatch, and it's giving you a longer span of data. So, you know, as Alice is showing, we've got all those enterococci results graphed over time. The clusters are because we only do it over the warmer months. So that's why we've got lots of data sort of between about October and March, and then nothing in between. Yeah. And then the ratings you see there, that's all, again, coming from sort of the Beachwatch methodology, and or the National Health and Medical Research Council guidelines. So you sort of base the enterococci, like 100 points of enterococci data, combine that with a risk rating for how likely it is that fecal contamination will happen at each of these sites, and that's how you come up with the beach suitability grade, which is like a annual rating that sort of gets updated once a year.
Yeah, no, and we've got links out to the Beachwatch website as well from the tool,
Yeah.
which is handy. And then the freshwater crayfish page.
So this is one of the funnest weeks of my year. Every November, we spend a week going out baiting traps and doing surveys of spiny freshwater crayfish in some of our creeks. We started doing that when we had an awful pesticide contamination incident that killed thousands of giant spiny crayfish in Wentworth Falls. And that sort of prompted us to reach out to an Australian crayfish expert, Rob McCormack, who since then has been coming once a year and helping us do these formal crayfish surveys. And yeah, having the Explorer is just a great way of being able to communicate those results. So Alice has it set up so that we're looking at all of the crayfish results from all the sites right now. You can also drill down, like do you want to select Jamison Creek? Yeah. That's where we had the first crayfish kill in 2012. So you can see that in 2013, the first blue bar there were not a heap of crayfish in the creek, and that's pretty steadily increased in the years since then. So good news story. That creek is back to pretty much being at capacity with lovely giant spiny crayfish, which are breeding each year and doing pretty well.
Yeah, that's fantastic. And then the waterway management page.
Yeah, so this is kind of bringing a lot of those strands of data together and trying to frame it in a way that makes it most helpful for people who are asking, like, what can we do about it? Or, so the waterway management page flags, I think there's now about 16 active management catchments, which we've identified as being the highest priority for intervention to manage. Mainly stormwater impacts is the big problem in our area. So, if there's a project happening, like council might be building a new car park or something, if it's in one of these catchments, it gives us a bit more impetus to say, like, we really need to be using best practice water sensitive urban design here. Or it might, that rating might help us support us in getting external grant funding, because we can demonstrate why these subcatchments are a high priority based on our data.
Yeah, fantastic. Well, thank you so much for walking through the dashboard. Hopefully everyone's had fun having a little bit of a play around with it. But that's the final dashboard. That took a long time for us to get there. What I want to do now is walk through the dashboard development process, because this was a very iterative and collaborative approach to designing this dashboard. And as Amy mentioned, our goal was really to take a lot of the discrete data sets and bring it together into one dashboard that can communicate quite clearly the key kind of trends and highlight the key data points in a way that the community can understand, but also thinking about the process of updating the tool as well. So there's a lot of moving parts here, and working with Amy and Alice from the Blue Mountain City Council, they hadn't worked with Power BI before. Power BI was new in their organisation. So what I want to do is step back and chat through the process of how you would actually go about starting a project like this, and what do you need to collate, and what's useful and what works. So the key steps we went through in this study was first having a look at the data. So we did a data review and exploration workshop. Then we developed a proof of concept dashboard. So this is where we imported the data, analysed and visualised the data sets, and quickly just created a proof of concept to convert those initial sketches into something tangible. Then we went around several rounds of iteration. The team would review it and refine the dashboard and the data, and then we would update it as well. Then we handed it over, so we integrated it into the Blue Mountains system. Then we did some enhancements for the public. So just making it really easy to navigate for the public, having a look at incorporating accessibility features where possible, adding things like a glossary and more instructional text for the general public. And we also did a little bit of Power BI training throughout the project as well. But this was really an iterative dashboard design process with lots of opportunity for feedback, collaboration, and really co-designing the tool. So if we take a step back and have a look at initially, what did the team provide? So they had a really quite a clear vision at the start of what they wanted to do and how they wanted to visualize this data. And after taking a look at the finished product, you might see some elements which you can identify really quickly in the dashboard. Oh, look, this made it all the way through to the finished product. But these were the team's initial sketches. So having a look at a catchment, having a look at the ecological, waterway health and water quality trends over time for all the catchments and the sites, and having that map showing a map of the catchment and the site locations. Having a look at all of those water quality trends as well. The water bugs, I think even initially the team had an idea of incorporating all of the nice photos and the information about the water bugs into the dashboard. Recreational water quality with different charts, having a look at the freshwater crayfish. So you can see that these sketches, they're nothing, they're not like neat or polished, doesn't show you how you would click through and what Power BI visuals would we use here and things like that. It's really just the team's vision on a page in a PowerPoint and a really clear way of communicating what the key themes are of the dashboard. Amy, if you can cast your mind back all those years when we first developed the initial prototype, when you were creating these sketches, was it fairly easy to do or?
Yeah, I mean, I didn't have a good sense of how Power BI worked or what was actually possible using the program. So I guess we just put together sort of our wish list of what was in our heads and what we wanted to be able to communicate easily to community and staff. And yeah, it's years since I've seen these initial sketches, and I'm amazed how like actually fairly closely they do mirror the final product. Obviously the final product is a million times more functional and a lot better than what these initial sketches managed to capture. But yeah, it's, you know, you brought our dreams to life. Thank you, Alice and Christian.
Oh, it's really good. It really shows that if you take the time to think clearly about your dashboard vision, and it's not just the sketch, it's also the data as well. You provided lots of extracts of data. Then we can bring it together, and it's just trying to see exactly what you said, what you would like to see in a dashboard, and then we know what's possible, and a lot of iteration in between. So this is really where the magic happens. Usually, initially at a study like this, organizations can develop a sketch, provide extracts of data, and then we can work together and create a prototype dashboard. Then the team sees this, they review and refine their vision and usually their data, and then we refine the dashboard and add in elements of automation. So in this study, I think the team initially, they provided us lots of extracts of data. And what we did was we collated that all together, created a bit of a data register. We saw all the data sources here and organized all their discrete Excel spreadsheets into one spreadsheet here initially. And then later down the study, then we actually integrated it into their Access database as well. So we're using Excel to provide some supporting information for all of the data which is contained outside of Access. But majority of the time series data is now contained in Access, and the dashboard talks directly to that. So that's kind of the dashboard development process. I've also got maybe one iteration if we have a look here. Just thinking about what happens from when we have a sketch, then we develop a proof of concept or a prototype. And then we can see we've got lots of questions of the data, but you can see in the first iteration, it was getting pretty close to the end product. There's lots of placeholders here while the team were collating things like the data or the images for the different water bugs. But that's generally the process that we go about. Were there any questions at this stage? So that's a bit of an overview of the project and the process. The next step, what I want to go through is some Power BI elements. So having a look at 3 common Power BI elements for an environmental study. So first we'll take a look up in Power Query and see some techniques of processing guidelines, thresholds, and exceedances, and then have a look at how we visualized them in this dashboard. And then I think we've touched on this a lot in lots of our presentations, but maps. Almost every environmental study needs a map. So we'll do a refresher of having a look at icon map and how we can display, how we can recreate a map similar to this one. And then chat about handling discrete data themes. So on lots of environmental studies, such as this one, we've got lots of discrete groups of data. So here we've got waterway health, we've got the water bugs, we've got crayfish, and just some of my kind of tips and tricks that I do to handle working with lots of those discrete data sets. I just had a question from Rita. Can you share the link to the published dashboard? We've shared it in the chat. I'm not sure when you joined. If you get access, I'll just copy it in again. Oh, Christian's beat me to it. Awesome. Okay. Well, if there's no other questions, I'll dive right in. So let's have a look at guidelines. So on almost probably 90% of the environmental studies that we work on, guidelines and thresholds come up, and they can be quite challenging. So this study, they're fairly simple, the guidelines, but they did have a couple of things that I can show you of how we processed the data to compute the exceedances. So as Amy mentioned, they go out and they collect lots of water quality parameters or water quality data. And for these parameters here, there are certain guidelines or thresholds that you want to maintain the water quality at an acceptable level. And these thresholds, they vary based on where the site fits within the catchment. So whether it's in the lower elevation, so less than 500 meters altitude, or whether it's above 500 meters altitude. Some of the parameters, things like pH or dissolved oxygen, they also have a range. So they have an upper and a lower threshold. So our challenge in this study was how do we assign these kind of spatially varying thresholds to our sites and parameters, and then how do we compute the exceedance? So really what we wanted to do is to calculate the percentage of exceedances at a given site for a given year. What we've got here in this query is our water quality data. So this data has been imported from the Access database. We're filtering the data just to keep the habitat that we're interested in this study, which is the edge habitat. And we can see that we've got all of our water quality parameters here along the top. We're removing the columns that we don't need, and then we're merging the data with our spatial data, because really what we want to extract is our altitude. So we need to know what the altitude is for the site so that we can assign the correct threshold. Now, with this data in this format, it's not very easy to do these calculations or create visuals in Power BI. What we're going to do now is one of my favorite transformations in Power BI, which is called unpivot other columns. So this is where we can convert all of those columns representing our water quality data and convert them into rows so that we can just do the calculation of the exceedance and the threshold essentially just once. So now our data's taking shape. We're going to split out the attribute here, do a few more cleanup steps. And now we're ready to merge it with our water quality threshold calculation table, just based on the parameter name, and expand out all of those thresholds. So we're getting pretty close here. What we want to do next is add some calculated columns. So if we have a look at this, we want to assign what is the lower threshold based on whether it is less than 500, then we want to choose this specific threshold, or if it's above 500, we want to choose this threshold. And we do the same thing with the upper threshold. And we can add one more calculated column in Power Query to compute whether a threshold has been exceeded or not. So just storing the exceedances as ones or zeros. So this demonstrates that we can use Power Query to do lots of calculations. These could have been computed within a database, but it shows that it can be computed here within Power BI as well. Other examples of guidelines and thresholds that we encounter aren't so neat. So sometimes the guidelines, they vary based on another parameter like EC, and you might have different thresholds based on whether you've got high EC or low EC, so they vary over time. Other parameters vary based on your windows of moving average or historical low or things like that. So they can be really, really challenging. But in this study, it was fairly straightforward. And then we'll be able to bring the data in. Here we're visualizing it as just a percentage of samples compliant with guideline thresholds. And then we saw on the ecological waterway health page that we could just basically have a look at the data over time here with these thresholds as well. So that's an example of something that's really common to lots of environmental studies. The next common element that I want to chat through quickly is having a map. So maps are really useful just to show visually where your sites are, but also on the map here you can see that we're also displaying using colour the health rating as well for the selected year. So one thing which is quite challenging to visualize on a map is your own custom polygons and points on a map. So we've done this in a couple of presentations. So I'll just go through it fairly quickly as a refresher, or if you haven't seen this before, then hopefully it's useful. We're using a custom visual called Icon Map. And Icon Map allows you lots of flexibility to create, really unique and bespoke maps. So its key fields that it requires is a category. So it's how do we want to split up our map. So I'm going to bring in an index field, and this is just a unique number for every data point I want to show in the map. So I bring that into the category and also into the size. Then I'm going to bring in the latitude and longitude for the points. So you can see initially we can just see where our sites are located, but not the catchments. So what we need to do is just add in the well-known text, or WKT, which represents our polygons. So here, if we bring this one in, and you can see that we can make this map with our own custom boundaries and points. We can apply a bit of formatting to the points. We've configured a rule here. I think that is, if we search, we've got lots of formatting. It's this one. Here we can see that we can conditionally format the color. We can format the border color, the border thickness. There's lots of options to customize this. If we want to take a step back and have a look at the data that informs this, that's this table here. You can see that we've got that index column, which is just a unique number for every data point we want to display on that map. For the sites, so those point locations, we've got longitude and latitude. And for the catchments, which are these last ones down the bottom here, that's where we've got that well-known text. So well-known text is a combination of your latitude, longitude kind of point pairs, which represent that polygon. So the key is just to have all of that data within the same table and think about how you want that map to interact. So the last common element that I wanted to chat about today is what my tips and tricks are for handling all of those discrete blocks of data. So we saw, if we have a look at the dashboard, we've got like our ecological waterway health, our water bugs, our water quality, crayfish, waterway management. There's lots of individual data sets. So we've kind of managed that in lots of different ways. If we, on environmental studies like this, we often end up importing lots of tables. So we have to keep organized. That's my first tip. Just try to keep yourself organized. Power BI, it's very iterative. We're constantly changing data, going back and forth. But at discrete stages in the project, try to take a whole point, go back and clean up and organize your data. So what we've done up in Power Query to help organize all of this data is group the data into their discrete themes. You can see like crayfish have their files here, site locations, water quality, water bugs. We're grouping the data together. Another thing which we do sometimes with our environmental data sets is just thinking about how are we naming the tables. So we've got discrete themes here. For crayfish, I'm going to name the tables very similar. So crayfish-data, crayfish-sites, crayfish-species. And the reason behind that is because it's a friendly name, so people can easily understand what it means. But Power BI in its data view, it sorts your data alphabetically. So that means that we can see those tables together. So it's a little bit easier for your Power BI developers to know what data is what. So just think about your naming conventions. Another tip is because we have so much discrete data, often these discrete data themes are their own mini data models. So you can see that we haven't really taken care to lay out our overall data model with much organization. It's just how Power BI did it themselves. And that's because I would probably never have looked at this master model. What we did instead was create these mini models, so these layouts, where we're bringing in our data just related to one theme so that you can really see how that data relates to each other. So if you're not familiar with creating new layouts for your data model, I'll just show you how I tend to do it. You just click on this plus icon here. Let's have a look at the water bugs, because that's what we're just having a look then. I'm going to drag in my water bug data table. So this is the fact table for the water bugs. So it should have majority of all the other related tables. So you can just right click on that and go add related tables. And then we can see all the tables that are related to this table, and we can collapse so that we can see just the related fields. And that makes it really easy, or much easier for people to unpiece or unpack how all your data is related together. usually our common linking fields for this study, I think, is date and our spatial location as well. So they're linking together all the themes, but within each theme, it's really nice just to have its own model view. And lastly, I think it was pretty obvious, we've laid out the report as these discrete themes. So each theme has its own page so that it's easy for users to navigate through, and even elements on the page, just organizing it. So even the bookmarks, we've grouped them and named them quite logically as well. So it's just trying to keep it organized because sometimes our environmental studies might have more than 50 tables in a Power BI report, and that's just because we have so much discrete data. So they were the 3 common elements that we found of Power BI. And I think that's where I wanted to leave it today. Amy, did you have any concluding comments or thoughts before we open it up for just general questions?
Microphone. I feel I should acknowledge that there's absolutely no way that we could have developed this Power BI report on our own. So having the expertise of someone like Alice and Christian has been like absolutely vital. Also acknowledging that my colleague, who's also named Alice Blackwood, has from Blue Mountains Council, and she's really been the driving force of sort of developing this over the years. And it was Alice Blackwood who first sort of encountered Enviro BI. I think she saw Alice or Christian present at a conference, and that's, you know, we knew we were looking for some way to better communicate our data, and Alice saw that presentation and knew that that could be the answer. So yeah, now Alice, my colleague, has recently left Blue Mountains Council, so I'm going to be in a steep learning phase in terms of actually updating and maintaining this Power BI report. So I think Alice Drummond and Christian can probably expect a few calls for support over the next few months.
Yeah. Oh, I think that it's been set up that yeah, Alice Blackwood had the hang of it. She just updated it and just the odd question here and there. But of course, yeah, it's a lot. Yeah. While it looks fairly simple, it looks really nicely presented, there's a lot behind the scenes because we're doing quite a few of the calculations internally, and there's just a lot of discrete data to get on top of. And being a public tool, then it's really important for it to just go through a bit of a QA process as well. But it's been an absolute pleasure to work with yourself and Alice on this study, and it's been really interesting just to see it. It's been quite a slow study. We did the initial dashboard creation and integration and handover all the way back in 2021. Then the team was using it internally, updating it, and I think it was just last year that you thought that it was ready to convert into public. And as we all know, working with Power BI, it gets monthly updates. So there were lots of things we could go back and streamline, especially the button navigator. That was really cool to bring in. So it's been a really nice study, and it's fantastic to see the position it's in today, and hopefully it will keep being used and updated for years to come.
Absolutely, and we need to do a data refresh. So anyone who's had a close look at the dashboard will see that, you know, it's been a little while since we updated the data that's feeding into that Explorer. So watch this space over the next few months, and there'll be a whole new batch of water quality and waterbug data in there.
Yeah, fantastic. Oh, so good. And just a quick, oh, actually, no, we've got a couple of questions here. Mike Honey asks, are you seeing much uptake of Icon Map Pro in your projects? Yeah, it's a great question. Icon Map Pro, for any Icon Map users out there, is, show you, it's a custom visual. It's James Dale's new kind of paid format of Icon Map. We haven't seen any uptake in our projects for Icon Map Pro yet. I think the sticking point for some organizations is that it is a paid app, and while the license fee, it's very reasonable, very small for the amount of benefit that you get. It's the need for other users to have the license, and especially thinking about how would we navigate with the public versions of the dashboard. Power BI sometimes can be a bit of a new software in organizations, and then adding paid licenses on top can be a bit challenging. So I think Icon Map, the original version, ticks probably 90% of the boxes. Icon Map Pro has lots of additional features, especially if you have lots of detailed data sets, and it's less clunky as well, but not at this stage. So hopefully soon we'll be able to play around with it more, but not yet. We had a question from Rita. How long did it take for your team to build this dashboard, please? Yeah, so the actual timeline itself, I think when we were working together, it was probably just 3 to 4 months. In the order of maybe it was 100 to 150 kind of hours of our time, maybe 150 hours to get the initial dashboard all together, including integration, handover, training, and then it's just been over the years providing ad hoc, so maybe 10 to 20, maybe 10 hours of support a year for the various updates, and then a little bit of extra time for converting it to the public version, just because it went through a few extra rounds of review. So from our perspective, this is a pretty small to medium size Power BI dashboard. There's nothing too complex here. But what people need to appreciate is that it's also the team's time. So Alice and Amy had to spend time thinking of the dashboard vision, collating sketches, providing that data, answering questions, being involved in meetings, getting internal feedback. So that's something to keep in mind if you're considering a study like this. It's not just how long it takes for developers like us to create it, but also how much time it takes for you and the team to support it as well. John hasn't been able to see the whole session, and you may have covered it, but how much effort or commitment is required to keep the data current? And what are the options and issues for live data feeds? Oh, that's a great question. For this study, I think, Amy, because you do the sampling fairly intermittently, it's to do with your sampling seasons. How many times a year would you typically update the dashboard? Is it just
so I think ultimately we'll probably be updating it maybe twice a year. For us, there's quite a lag in terms of collecting the field data, and then there's sort of other steps that we need to finish off, like completing macroinvertebrate ID with microscopes, the things that we can't ID in the field because they're too small, or you need to see the little details. So in terms of the time it takes to keep data current on the Power BI report, it's not much more than just what it takes us to keep our data current in our databases. So that's the time for us, is taking all these different strands of data and entering them into our databases. From there, it's a manual process to then update the Power BI report and publish the new version to the web. But that process in itself is not very time consuming. And it's our data isn't live data. Like it's, you know, we don't have sort of permanent water quality probes out there continuously collecting data. I don't know, Alice or Christian could answer whether that is an option if you've got like a different style of data collection. Ours is just very much spot samples. Yeah, so I'll let Alice answer that.
Oh, no, it's a great question. It's something to think about. And it's a good point. Your data doesn't get updated very frequently, so we shouldn't invest much effort in automating the refresh. If all the data was entered into the Access database and supporting files in the same format, it'd be as simple as pressing the refresh button and then checking it and publishing it. So we haven't automated it in the service because doesn't get updated very frequently. We do want the team to have a manual check and then publish. So if it all worked fine, the process would take half an hour. If you're thinking about another study, we've worked on studies. I think we presented at one at this group on, say, like Damien Snell's dredging dashboards, where we've got live feed of data coming in from the marine tracker to track all of the vessels and things like that. And that can get updated every 3 to 4 minutes. So we've got live direct query in dashboards, and that works as well. So it really just depends on your data sources, and seeing what works. Another question, where do we get the sample data sets and what's the data sources for this project? The data for this project, is that publicly available, Amy?
Yeah, I mean, we consider our data to be public data. You know, it's the only form it's sort of available without coming to us and asking for raw data is through this Power BI report. If anyone's interested in sort of digging a bit deeper into the raw data, you're welcome to contact me. I can put my email address in the chat. And yeah, happy to talk about that. But it's all collected by Blue Mountain City Council staff. So that's where the data comes from.
Fantastic. And the data sources for the project, this one, it is just, we have a look here. It's just Excel and Access. So we got the waterbugs and water quality access database and some supporting information, which is specific for the Power BI report in an Excel spreadsheet. So it's nothing fancy. It's not it's just when you're thinking about the data sources for these studies, you have to weigh up what you've already got within your organisation, what people use, and what the team are able to update and maintain. So the team had an Access database, and Excel is really widely used. And I think final question from Matthew, as far as visual tools go, do you have experience with Grafana and pros and cons against using Power BI? No, I don't. At Discovery Eye, we specialise just in Power BI. So I don't really look outside of Power BI. But if you're on the call, did you want to chat through what your experience is, Matthew?
Yeah, I haven't used Grafana. Just interested in the tool for using maybe visualizations against time series data. But yeah, I haven't used it. I just wondered if you had experience with it.
Yeah, no, there's so many great tools out there. But then there's so much to learn in Power BI. So we struggle to keep up to date with all of the new Power BI features. So no, we just try to focus in on that, but it's always useful to have a look at what's possible in other programs and platforms as well. And if there are very specific ways that you wanted to visualize time series data, or especially the problem of the exceedances, they are actually quite tricky to visualize in Power BI. You've got a custom visual library here, which has lots of additional visuals which might meet your need. And if that's not available, then Daniel Marsh-Patrick, who works with us at Discovery AI, he's actually created a custom visual called Deneb, which allows you to really easily code up your own bespoke visuals in Power BI. So it does require a little bit of coding knowledge of Vega Lite, which is a bit of a learning curve, but there's heaps of templates out there in the community as well. And so when we can't do something in Power BI using the core visuals or the custom visuals, then we're very lucky. Daniel just whips up a Deneb visual. He did one for us last week, which was really cool to show exceedances for some groundwater trends over time, where we are putting on the line chart markers for each sampling point and colouring those markers, whether it's exceeded or not. So red, amber or green. And that sounds really quite basic, but you can't do it with multiple time series in Power BI, and we had a lot of data, so it exceeded the 10,000 data point limit, and on the core visuals it kind of maxes out, but he has an override for this, so we could display I don't know, like up to, it was a little bit slow to render, but like 200,000 data points. He did a really cool technique for it as well, which he was very excited about. I think he might write up a blog article on it, so watch this space, but that's an option. So we kind of stay within Power BI, but then get around some of the constraints by creating our own custom visuals. Were there any, I do know we're just over time, so I'm happy to stay on for a minute or two if there are any further questions. But just to wrap up, as Christian mentioned at the start, we'll be saving a copy of the recording and our key takeaways on our blog and YouTube channel as well, and posting it in the meetup group. And we are always looking for new presenters. So we've got a couple more lined up. We just have to lock in dates. So watch this space. But please, if anyone has a Power BI journey that they've been on, or a really cool environmental example they want to share, it doesn't have to be a full hour. It could just be 5 minutes, could be half an hour. Please get in touch. We would love to have you on. We're always looking for new and interesting presenters. But thank you so much for dialing in, and a big thank you to Amy for presenting with us today. It really adds so much more context and value just hearing about the data and how it can be applied firsthand. So thank you so much, Amy, and looking forward to seeing everyone next time.
Thanks, Alice. Thanks, everyone.
Thank you.
Thank you. Thank you.
Thank you. Bye.
Thanks.
Talk
See
to you later. Bye.
Yeah, I'll talk to you later. See you, Amy. I'm going to jump off.